Assalamu alaikum everyone. This is not discrete random variable. I've already done discrete random variable. I've done discrete random variable. I've done probability, so I will not be doing that again. This, inshallah, in this stream, inshallah, I will do geometric, and I will do क्या बोलते हैं? I'll do geometric and I'll do normal. ठीक है? So expect this to be a slightly long stream. अच्छा ठहरो, let me just fix the title. फिर we'll start. Permutations tomorrow inshallah. Permutations की कल हम एक detail stream करेंगे inshallah. Sir, do you know Sir Ahmed Saya? Sir Ahmed Saya was my teacher here. Of course I know him. Just saw a discrete random variable fit you. Acha, chale. Good for you. I hope it helped. Yeah, this is 2020 onwards. Why? Because geometric distribution was added in 2020. Do I know Sir Zain? Of course I know Sir Zain. Yeah. Mock S1 का mock मुझे होता मुश्किल नज़र आ रहा है because we're really short on time. So I don't know if there will be a mock or no. Can I cover all of AdMath over the summer if I didn't do it earlier on? Why would you want to do it? Sir, I know how to do normal distribution, but I keep messing up the value of z to take from the chart, whether it should be negative, positive, or otherwise. So we'll do normal distribution, don't worry. Yep, he was my teacher. Do you know Sir Rohab? No, I'm afraid I don't. Why did they even have to add geometric distribution? We're way better off it. Okay, that's a different debate altogether, but it's fun. Might as well do it. I struggle with perm and com. I'm doing that tomorrow, inshallah. I'm doing that tomorrow. Is it a good idea to do further math? Mariam, you're a further math student, right? So you answer that question. Do I know Sir Farooq Ahmed Siddiqui? Of course I know Sir Farooq Ahmed Siddiqui. He was also my teacher. Sir Farooq Ahmed Siddiqui was my teacher. In the sense, he was not like my teacher like Sir Ahmed Saya was, but he was teaching in the same school. Not in the same school, the same institute that I used to go to. So, do you know Sir Irfan Ahmed? Sir Irfan Ahmed, I'm afraid I don't, but I might know him by face, not by name. Sir Wasim Taj, I've heard that name. I haven't met him ever, but I've heard of him. When will you start P3? Shayan beta, were you sleeping today? I think you've just woken up. I've already done P3. I mean, I did one stream of P3 already. Tomorrow, inshallah, I'll do another stream of P3. Okay? Okay, now let's resume now. ठीक है, अब आप लोग मेरा इंटरव्यू लेना छोड़ें. Let's resume. Okay. Sir Hamza Shafiq. There are so many Sir Hamzas. I don't know which Sir Hamza Shafiq you're talking about. I don't know. Physics? Sir, no, wait. Physics, no. I don't know. Hey, anyway. Achha, just because I don't know does not take anything away from the teacher. Okay? It's just that I haven't been teaching in schools for the past 2-3 years, so I'm not completely aware of who's who. Okay? So, yeah. Okay? Yeah, of course I know Sir Shahab Yaqub. Of course I know him. Hamza Shafiq is eco teacher in... Okay. Chale. Achha, let's resume. We have a lot to cover. Okay, and that will take a while. So let's begin. Achha, we are doing geometric distribution. Now, geometric distribution is very simple. It's kind of similar to binomial distribution, except that there is no formula. There's no formal formula that you have when it is similar to normal distribution and binomial distribution. Okay? So first, let's go over some rules of geometric distribution. Then we'll see how it works. So in geometric distribution, the number of trials are not fixed and they continue until a desired outcome, which is considered as success, is achieved. For examples, the number of times you take an exam until you pass. You never really start with a number in mind. Okay, if let's say, for example, there's a university that you really want to get into, or for example, let's say you want to get your driving license, so you don't really start with a number in mind, you keep on trying till you pass. Okay, so number of trials is not fixed, whereas in binomial, you would have questions where 10 people are chosen at random. Okay, or maybe you would have 10 days are selected or 5 weeks are selected, but here the number of trials are not fixed. Number of job applications before first acceptance, so it's not that you start, I'm only gonna apply in 5 different places and that's it, I'll stop. No, you keep on applying till you get accepted. Okay, till you basically get your first acceptance. Number of times calling someone before someone answers. Again, here the number of trials are not fixed. Tossing until first head is obtained. So tossing until first head is obtained means that you'll keep on tossing the coin till you get the desired outcome, which in this case is head. Now, probability of success and failure is fixed, not like regular probability where if you take one out, the probability decreases. That's not the case over here. Similar to binomial, the probability of success and failure is fixed. So how do you calculate mean or expected value of x? It's basically equal to 1 upon p, where p is the probability of success. Now, for the first success to occur on rth trial, r minus 1 trials must fail. Meaning, if you want your first head on the 6th trial, that means the first 5 trials should not give you heads. That means the first 5 trials should give you tails. Or let's say if the person answers the call the first time on the 7th attempt, that means the person didn't answer in the first 6. Okay? So, whatever trial you get your first success on, prior to that, you didn't get success. That means 1 less than that would be the number of failures. So for example, if you clear the test the first time in the 10th attempt, that means you didn't in the first 9. Okay. If let's say you get your first acceptance letter after applying in 7 different places, that means you did not get it in the first 6. Okay. After the first 6. So tails is obtained first time on the 7th trial. This means that head is obtained in the first 6. Okay. Now this is the formula where r is the number of trials required to achieve the first success. So if the first success requires r number of trials, that means r minus 1 trials must result in failure. Okay. अच्छा, अब हम एक काम करते हैं. Let's have a look at these standard rules. Okay, so there are some standard rules in place, and how we use these standard rules, we'll talk about them. Okay, so these standard rules you can either memorize or you can just use your common sense and see how it works. Okay, so let's solve a few questions. Let's solve a few past paper questions and see how it works. So this is the very first geometric distribution past paper question. This is from February-March 2020, paper 5, variant 2. Let's see what it says. An ordinary fair die is thrown repeatedly until a 1 or a 6 is obtained. Ab dekho, how do you know that this is a question of geometric distribution? Whenever you see something that until so-and-so is obtained or until so-and-so is done. That is how you know that this is a question which follows geometric distribution. Okay. Now, what is the success? What is considered success over here, and what is the probability of success? 1 or a 6 is basically considered success. So that means the probability of getting a 1 or 6 is basically equal to 2 upon 6, which is equal to 1 upon 3. So this is the probability of success. So the probability of success is 1 upon 3. That means the probability of failure will be 2 upon 3. Okay. Now the question says, find the probability that it takes at least 3 throws but no more than 5 throws to obtain a 1 or 6. So at least 3 throws but no more than 5 throws means that probability of x is greater than or equal to 3. Okay. At least 3 throws means that the first success is achieved after at least 3 throws, and not more than 5 throws. That means lesser than or equal to 5. Okay. So greater than or equal to 3, lesser than or equal to 5. Yes, I will do a full syllabus run through, guys. Don't worry, I will do it. Okay. How about right now we focus on what we're doing. Okay, so let's find out the probability of achieving the success on the 3rd trial. What is the probability that the first success is achieved on the 3rd trial? That means the first 2 must have resulted in not success. That means 2 upon 3. So it's basically not success, and then success. So 2 upon 3, the whole thing square, into 1 upon 3. Okay, whatever that is equal to, we'll work it out. And what is the probability of achieving success for the first time on the fourth trial? That's going to be 2 upon 3 raised to the power of 3 into 1 upon 3. Why? Because achieving success for the first time on the fourth trial means that you don't achieve success in the first 3. And then finally the fifth trial. Okay, so the fifth trial basically means 2 upon 3, the whole thing cubed, into 1 upon 3. Okay, and why are we considering third, fourth, and fifth trial? Because the question said that the probability that it takes at least 3, but no more than 5. So that is why we're considering 3, 4, and 5. Okay. Now let's work this out. 2 upon 3, the whole thing square into 1 upon 3. So 2 upon 3, the whole thing square, bracket open, 1 upon 3. This is equal to 4 upon 27. Then we have 2 upon 3, the whole thing cubed into 1 upon 3. That's equal to 8 upon 81. Actually, wait, this will be equal to 4. Yeah. Then 2 upon 3, the whole thing power 4 raised to the power 1 upon 3. What's that equal to? That's equal to 16 upon 243. Okay. Now what we're going to do is we're going to add them up. So you add them up. What do you get? So 16 upon 243 plus 4 upon 27 plus 8 upon 81. So add them up and you get your answer, which is equal to what? Which is equal to 76 upon 243. And that's it. This is the probability that the first success, which is obtaining either a 1 or 3, a 1 or 6, it takes at least 3, but no more than 5 throws. Okay? Now, pretty basic. Don't expect every single question to be so basic. Let's do some more questions. All right, question number 2. A pair of fair coins is thrown repeatedly until a pair of tails is obtained. All right, we're talking about what? We're talking about a pair. Okay, so keep that in mind. The random variable x denotes the number of throws required to obtain a pair of tails. Find the expected value of x. Okay, now if you want tails in both, okay, that means it has to be 1 upon 2 into 1 upon 2. Okay, we're talking about fair coins and we're talking about 2 coins. So the probability of success has to be 1 upon 2 into 1 upon 2, which is equal to 1 upon 4. Okay, but since we have to find out the expected value of x, the expected value of x is equals to 1 upon p, which means it's going to be equal to 1 over 1 upon 4. You don't have to do all this working. It's a 1 mark question, so you just get marked for writing the correct answer. But I'm just doing it so that in case you don't know how it's done, here it is. Okay, so that's the expected value of x. Find the probability that exactly 3 throws are required to obtain a pair of tails. Now, what is the probability of success? The probability of success is 1 upon 4. What is the probability of failure? The probability of failure is 3 upon 4. So if it takes exactly 3 throws for the first success, that means the first 2 must fail. Okay, must result in failure, which means 3 upon 4 to the power 2 into 1 upon 4. Okay, if it takes you exactly 3 attempts to clear the test, that means in the first 2 you didn't clear the test. ठीक है, हमेशा एक टेस्ट वाली एग्जाम्पल लगाया करो, समझ आ जाएगा. So 3 upon 4, the whole thing square, into 1 upon 4, what is that equal to? That's equal to 9 upon 64. That's it. Now, find the probability that fewer than 6 throws are required to obtain a pair of tails. So fewer than 6 means what? Fewer than 6 means that x is less than 6, which if you think about, means that it could be 5, 4, 3, 2, 1. Okay, which is not a good idea. Okay, which is clearly not a good idea. So this is a question from May June 2020, paper 5, variant 3. Okay, this is, it's possible, but not a good idea. Okay, not a good idea. Okay, so what can we do? What would be the opposite of x is less than 6? The opposite of x is less than 6 would be 1 minus the probability of x being greater than or equal to 6? Okay, so the opposite of x is less than 6 would be 1 minus the probability of x is greater than or equal to 6. अब मुझे एक बात बताओ. Here's a question for you guys. Okay, so drop everything that you're doing and just listen to what I'm saying. If it takes you at least 6 attempts to clear a test, so what did you do in the first 5? If it has taken you, okay, or if it takes you at least 6 attempts to clear a test, what does that tell you about the first 5? If it takes you at least fail, that's it. That means finding the probability of x is greater than or equal to 6 is the same as finding the probability of failing in the first 5. Okay? So this would be 1 minus the probability of failure, that's 3 upon 5, raised to the power of 5. Okay? There you go. Zilalat in first 5. Jana, that's one way to put it. So here it is. Here's the answer. And what is this equal to? This is equal to 781. Yeah, you can use the formula. You can use the formula, but my question is कि कितने formula याद रखोगे? कितने formulas याद करोगे बेटा? तो क्यों ना थोड़ी common sense use कर लो? ठीक है, ये formula हम लगा रहे हैं यहाँ पे. There's always a formula, okay, but treat formula as plan B. Achha, you can also use sum of GP. I haven't seen that ever used in the marking scheme, but I've figured it out that it is allowed. But you can actually do it the longer way, and since the progression will be a geometric progression, so you can use sum of GP also. Okay? So आप ये formula भी use कर सकते हैं. But notice that I treat this formula as a plan B. Okay? Note, if it takes at least 3 trials to achieve success, that means first 2 must have resulted in failures. Okay? So आपने x निकालने के लिए ex use क्यों किया? The question said expected value of x. Expected value of x is e of x. Okay? All right. So sometimes when someone calls someone and they don't pick up, then the first time, then they don't call them again knowing that they are. ठीक है, I agree. But अगर आप एक insurance agent हैं तो you'll keep on calling till the person picks up. ठीक है? Or maybe a friendship is not strong enough कि वो एक दफ़ा कॉल करके उसने छोड़ दिया. Hello sir, I'm an IGCSE student. Chana, I appreciate that. Achha, I'll repeat. Okay. Achha, don't worry. If you don't get a concept, we'll solve plenty of questions similar to this. Okay. So you will get it. So the question says, find the probability that fewer than 6 throws are required to obtain a pair of tails. Now, fewer than 6 means could be 5, could be 4, could be 3, could be 2, could be 1, not 0. Okay, you can't have 0 over here. Okay. Now, fewer than 6, like I said, could be 5, 4, 3, 2, 1. Now, you could find out exactly how we did here. Here we found out the probability of achieving success in the 3rd, 4th, and 5th. You could do the exact same thing for these 5 values. But obviously, that's not a good idea. Okay. That's a horrible idea, in fact. So instead, what we're going to do is, we're going to see if there is an opposite way. Okay, in probability, when finding out one way becomes very lengthy, what we do is, we do the opposite and we subtract it from 1. Okay, if the opposite is shorter, we do that and we subtract it from 1. So that's what we're going to do. We're going to do the opposite of lesser than 6. What's the opposite of lesser than 6? It's greater than or equal to 6. And because it's the opposite, that's why we're subtracting it from 1. Here's a question for you guys. If it takes you at least 6 attempts to clear a test, what is that the same as? That's the same as not clearing them in the first 5. Okay, if let's say it has taken you 6 attempts to clear a test, or if let's say it has taken you 6 job applications to land your first job, that means you got rejected in the first 5. So it's the same thing. So the probability of taking at least 6 attempts to be successful is the same as not being successful in the first 5. That's it. Okay. Achha, we will do binomial plus geometric, don't worry about that. And we will do binomial plus normal when we start normal distribution. Okay? Why not 0? Beta, is it possible that you answer the call without someone calling? Is it possible that you clear the test without actually appearing for it? it's not possible, right? You still have to do something. You still have to basically attempt to get the first success. You have to make one attempt at least to get the first success. Okay? So obviously it's not possible कि zero पे आपको success हो जाए. Is it possible to get a tails without tossing the coin at all? बताओ मुझे. ऐसा possible है? नहीं ना? खैर कोई बात नहीं. I'm glad you asked, but here's the answer. अच्छा, let's see what it says until the score. Okay, let's do this. When the score when two fair six-sided dice are thrown is the sum of the two numbers on the upper faces. Show that the probability that the score is 4 is 1 upon 12. Achha, how can you get a 4? You can get a 4 if you get a 1 and 3. So that's one way that you can get a 4. You can get a 4 if you get a 2 and 2. Another way that you can get a 4 is if you get a 3 and 1. Okay? So don't expect a question of geometric distribution to just be geometric distribution. You may come across some basic probability. So this means that the probability that the sum is 4 is equals to 3 upon 36. Why 36? Because you're throwing two fair six-sided dice. That means 6 times 6 equals to 36. And the favorable outcomes are 3. So 3 upon 36, what's that equal to? That's equal to 1 upon 12. Okay? Now, the two dice are thrown repeatedly until a score of 4 is obtained. The number of throws taken is denoted by the random variable x. Okay, so what is the success? Success is basically achieving a 4, and what's the probability of that? The probability of that is equals to 1 upon 2. So how will you calculate the mean of x? The mean of x will be 1 upon 12, and what's that equal to? That's equal to 12. Okay, now find the probability that a score of 4 is obtained on the first, that a score of 4 is obtained, that a score of 4 is first obtained on the 6th throw. Okay, so the word first is very important. And this is obtained exactly on the 6th throw. Not at least 6, not more than 6, exactly on the 6th throw. So we need to find out the probability that x is equals to 6. अब मुझे बताओ, अगर आपने अपने एक टेस्ट को 6th attempt में जाके क्लियर किया है तो पहली 5 में क्या किया आपने? और if let's say you got your driving license after giving 6 on the 6th attempt, what happened to the first 5? Fail. Exactly. ठीक है? So this means that we will take the probability of failure, which is 11 upon 12, raise it to the power of 5. So this is the probability of failing, raised to the power of 5 into the probability of success. That's it. Okay, so let's work this out. You have 11 upon 12, the whole thing raised to the power of 5 into 1 upon 12. And do we get it in fraction form? No, we don't. So this is equal to 0.053935 ... correct to 3 significant figures. It's going to be 0.0539. There we go. Okay. Now, find P. Find the probability that x is less than 8. Meaning the first success or a 4 is obtained the first time in fewer than 8 attempts. How did I get 11 upon 12? But if the probability of success is 1 upon 12, what would be the probability of not success? That's 11 upon 12. Okay. So the probability of x is less than 8 is basically equal to what? Basically means the probability that you get your first success on the 7th, 6th, 5th, 4th, 3rd, 2nd, 1st, which clearly is not a good idea. Okay. So let's do the opposite. Let's do the opposite of x is less than 8. What would be the opposite of x is less than 8? The opposite of x is less than 8 would be x is greater than or equal to 8. Now, since we have worked out the opposite, whenever we work out the opposite, what do? We subtract it from 1. So we're going to subtract this from 1. Now, what is the probability that it takes at least 8 attempts to achieve your first success? That means not achieving success in the first 7. That's it. Okay. So taking at least 8 attempts to clear a test is the same as not clearing it in the first 7. Okay, so you work this out, what do you get? You get 0.4561488, and then correct to three significant figures, it's 0.456. There we go. Okay. All right, now let's do some recent questions. Enough of the old ones, let's do some recent ones now. एक सवाल आता है जिसमें हाँ ये करते हैं. This is nice. Rajesh applies once every year for a ticket to a music festival. The probability that he is successful in any particular year is 0.3 independently of other years. Yeah, I'll do October, November also. Okay. What if you didn't attempt the exam at all? That's the same as, then there is no outcome. Okay. See, for success or failure, you have to have at least one trial. Okay. Now, find the probability that Rajesh is successful for the first time on his 7th attempt. So the first time that he gets a ticket to a music festival on his 7th attempt means that he does not in the first 6. So the probability of success is 0.3, which means the probability of not success will be 0.7. So 0.7 raised to the power of 6 and 0.3 raised to the power of 1. I gave your dog trauma. Okay. क्यों भाई ऐसा क्या हो गया उसको? 0.7 to the power of 6 into 0.3. What is that equal to? That's equal to 0.0352947, which correct to three significant figures will be 0.03529. No, 0.0353 actually. There we go. Okay, now find the probability that Rajesh is successful for the first time before his 6th attempt. Again, before his 6th attempt means that x is less than 6, which means it could be 5, could be 4, could be 3, could be 2. So we're going to do the opposite. We're going to do the opposite of less than 6, which means greater than or equal to 6. Now, because we have done greater than or equal to 6, that means we're going to we've done the opposite. That means we're going to subtract from 1. And what is the probability that it takes him at least 6 attempts to land his first ticket? That means not being able to in the first 5. So 1 minus 0.3, 1 minus 0.7 raised to the power of 5. So 1 minus 0.7 to the power of 5, that's equal to 0.83193. Now, because this is the exact answer, we're not going to round it off. Okay? ये exact है, ये एक point पे आके रुक गया, we're not going to round this off. Okay? Now, what about this? Is this binomial? Is this geometric? Find the probability that Rajesh is successful for the second time on his 10th attempt. So second time bhi hai or 10th attempt bhi hai. What does that mean? How do we identify geometric and binomial? I always get confused. But we have far bigger fish to fry and identifying geometric and binomial is not one of them. देखो, जहाँ पे भी क्वेश्चन बोले ना for the first time or until so and so is obtained, that is geometric. Okay, but the second you see the number of trials being fixed, that means it is binomial distribution. Okay, like for example, 10 people are chosen at random, or 10 days are selected, or 10 so and so are selected, 10 weeks are selected. That is how you know that this is binomial distribution. Okay, in geometric you keep on doing till you achieve your first success. Okay, now a question for you guys: is this binomial? Is this geometric? This is both. Okay, it's a bit of both. It's a mixture. So isn't it going to be 0.7? No, it's not going to be 0.7 raised to the power 6. It's going to be 0.7 raised to the power of 5. Why? Because x is greater than or equal to 6 means that it takes you at least 6 attempts to achieve your first success. That is the same as not achieving success in the first 5. Okay? Ab dekho, I will do it both ways. Okay? I will do it using binomial and I'll do it without binomial also. Okay? So notice that the question says that the second success is achieved on his 10th attempt. Okay, so let's make 10 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I do not recommend that you do this in the exam. Okay, I'm just doing it right now so that you understand the concept. Okay. So notice that this is his 10th attempt. Okay, and this must be a success. Okay, this must be a success. But as far as the first 9 are concerned, okay, as far as the first 9 are concerned, we just need 1 success in the first 9 attempts. Okay, so as far as the first 9 are concerned, we just need 1 success in the first 9 attempts, and that can happen in any order. So it could be that he fails, ठीक है, success and then fails. ठीक है. Now this can happen in any order. Okay, whereas this being successful on the 10th attempt is non-negotiable. Okay, this cannot change. Why? Read the question. The question does not say that out of 10 he must be successful 2 times. No. The question says that the second success must be on his 10th attempt. That means the 10th attempt has to be a success and it has to be the second success. So you can see that this is success number 1, this is success number 2. Okay? What if it said a third time? That means in the first 9 he can have 2 successes, but the third success, if the question says that he is successful for the third time on his 10th attempt, that means the 10th attempt must be his third success. First 2 can happen in any order. Okay? Yeah, there are many questions similar to this, so we'll do them, don't worry. Achha, since this can happen in any order, here's what we're going to do. First, I will do it using factorial, then I'll do it using binomial. Okay, and they're both the same actually. Factorial method is not any different from binomial. It's just that you write down the expanded version of binomial. Okay, so this is the factorial method. Now notice how many failures do we have? We have 1, 2, 3, 4, 5, 6. No, wait, 1, 2, 3, 4, 5, 6, 7, 8. So that means 0.7 to the power of 8. Okay, into 0.3. ठीक है, ये किसकी बात हो रही है? ये बात हो रही है फर्स्ट 9 attempts की. ठीक है, and because they can happen in any order, what are we going to do? We're going to do 9 factorial divided by 8 factorial into 1 factorial. Okay, because think of it this way, these are 9 letters. Okay, so 9 factorial, but of these 9, 8 of them are the same. That's 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 factorial into 1. Okay, so this is basically for the first 9 attempts. Okay, all this working that I'm doing, okay, मैं ये method recommend नहीं करता. Okay, I recommend using binomial obviously, but I'm just doing it anyway. So this working that you see is basically for the first 9 attempts. Okay, now what about the 10th attempt? Since the 10th attempt has to be a success, we're simply going to multiply it by 1. बेटा 1 factorial कर लोगे तो क्या हो गया? मतलब कोई पुलिस आ जाएगी आपके घर पे? ठीक है. What difference does it make अगर आपने कर भी लिया 1 factorial तो? हाँ? इसमें इतना परेशानी की क्या बात है कि मैंने 1 factorial कर दिया? So 0.7 to the power of 8 into 0.3 into 9 factorial divided by 8 factorial, ठीक है, into 0.3. ठीक है. So 0.7 into 0.3 into 9 factorial divided by 8 factorial into 0.3. That gives us the answer, and what's that equal to? That's equal to 0.404669, which means ये हो जाएगा 0.0467. ठीक है. अच्छा, अब I will give you another method, ठीक है, which is the method that I recommend. So this is the method that I recommend, and this is binomial. Factorial नहीं समझ आया? Nothing to worry about. ठीक है. It's not even that important. Okay. since the first 9 attempts, in the first 9 attempts, you only want one success. So that means what you can do is, since it can happen in any order, that means you can use binomial theorem. Okay, since in the first 9, you only want one success and it can happen in any order, what you can do is you can use binomial theorem. Sorry, not binomial theorem, binomial distribution. Binomial distribution. Okay. So this means 9C1. So notice that there are 9 attempts in total, from which we just want one success. So that means 0.3 raised to the power of 1. And then 0.7 raised to the power 9 minus 1. What's that equal to? That's equal to 8. So this is for the first 9 attempts. And then what about the 10th attempt? For the 10th attempt, it has to be a success. This is non-negotiable. So this is the 10th attempt. This is the method that I recommend. Okay, factorial method is just for fun, not something that I recommend. Okay, so this is for the first 9 attempts. And then for the 10th attempt, it's 0.3. And you'll get the exact same answer. You'll get 0.046. That's 0.04669. 0.04669, which correct to 3 significant figures. You get 0.0467. There we go. Okay. Okay. Can't it be done by permutation? I did it by permutation. Factorial is permutation. Same thing. Okay. Okay, now. Let's do more such recent questions. Sir, can you teach approximation? Yeah, I will teach approximation in normal distribution. Okay, so take it easy. All right, another question very similar to the previous one. Salah decides to attempt the crossword puzzle in his newspaper each day. The probability that he will complete the puzzle on any given day is 0.65, independent of other days. Find the probability that Salah completes the puzzle for the first time on the 5th day. Okay, for the first time on the 5th day. 9C1 nahi samajh aaya? Dekho, because it's binomial, because it can happen in any order, that's why we're doing 9C1. Okay, because in the first 9 attempts, you can get your first success in any order. That's why we're using binomial. Okay, and whenever we use binomial, what do? We look at the number of trials. So there are 9 trials in total. We want one success, so 9C1. Probability of success raised to the power of number of successes that you want, which is equal to 1. And then you have 0.7, which is the probability of not success multiplied by 8. No, it's not going to be 9P1. It's going to be 9C1. It's not binomial में P कब से होने लगा मरियम? Since when did we start having P in binomial? Why is part C crossed? Because it's not geometric, it's binomial, but chalo, we'll do it. ठीक है. अच्छा ये कोई और सी ऐप है, but we'll do it, it's okay. Salah decides to attempt the crossword puzzle in his newspaper each day. The probability that he will complete the puzzle on any given day is 0.65, independent of other days. Find the probability that Salah completes the puzzle for the first time on the 5th day. So if he's completing it for the first time on the 5th day, what does that tell us about the first 4? 0.65 raised to the power of... 0.65 nahi. P is 0.65. Q kya hoga? Q hoga 0.35. That means the first 4 days he is not completing it. So 0.35 raised to the power 4 into 0.65. तो पहले 4 दिन नहीं किया, फिर finally कर लिया. ठीक है? So this is question number 22. 0.35 to the power 4 into 0.65. And that's equal to, let's see, 0.009754062, which correct to 3 significant figures, will be 0.00975. There we go. Okay. How long will the stream be? 8:30 to kahin nahi gaye beta. Find the probability that Salah completes the puzzle for the second time on the 5th day. Okay, second time on the 5th day. That means first 4 में सिर्फ एक success चाहिए, can happen in any order, so the first 4 will be treated as binomial, whereas the 5th day has to be a success, and that's non-negotiable. Okay, so P, Q, Q, Q. Okay, so this is binomial because it can happen in any order. whereas this is non-negotiable. Okay, so for C1 we just want one success, so that's 0.65 raised to the power of 1 and 0.35 raised to the power of 3. So this is for the first 4 days, and then for the 5th and the final day again 0.65. Okay, so let's work it out. 0.35 the whole thing cubed into 0.65 the whole thing squared into 4. So we get 0.0724585, which correct to 3 significant figures will be 0.0724. That's it. Hey, 245. There we go. So how to write 3 significant figures of 0.00, 0.666? That's correct. So I want to get distinction in maths. How much? But you have to score full. You have to basically score full marks and then some. What do I mean by that? That means a lot of people will end up getting full marks, but not everyone will end up getting distinction. But then after full marks, it comes down to the quality of your working. Boring हो गया, मुश्किल सवाल करवाएं. चले अभी करवाता हूँ मुश्किल सवाल. Hold on. Find the probability that Salah completes the puzzle fewer than 5 times in a week, 7 days. Acha, what is this? Is this geometric? Is this binomial? Is this... What else is there? Normal? Clearly not normal. I hope nobody confuses this for normal. It's clearly not normal. What else is this? Geometric है, binomial है, क्या है? ये है binomial. कैसे figure out क्या? How did you guys figure it out? It's fixed because we are talking about a fixed number of days. The number of trials are fixed. That means it's binomial. Okay. Find the probability that Salah completes the puzzle fewer than 5. That means we need to find out the probability that x is less than 5 out of 7. ठीक है, अब ये हम नहीं कर सकते. So instead we're going to do the opposite. We're going to find out the probability that x is greater than or equal to 5. Okay? But this is not binomial, so don't think that you can just take the probability of failure and raise it to the power of 4. This means that we will find out the probability of 5, 6, and 7. Okay? Now, 1 minus what is the probability that out of 7 he completes the puzzle 5 times? So that's going to be 7c5, 0.65 raised to the power of 5 into 0.35 raised to the power of 2. रोज स्ट्रीम करके आप लोगों को मेरा स्केड्यूल भी याद हो गया. 7c6 I have tea after Maghrib because it says greater than or equal to 5, so obviously I'm going to consider 5, 6 and 7. ठीक है, 0.65 raised to the power 6 and then 0.35 raised to the power of 1 and then finally 7c7 0.65 raised to the power of 7 into 0.35 raised to the power of 0. अच्छा, यहाँ पे क्यों ना हम अपने कैलकुलेटर का इस्तेमाल करें? क्या ख्याल है? अच्छा, हमारा थोड़ा बाइनोमियल भी प्रैक्टिस हो जाएगा. Because you have to show the values that you get, okay? So you have to use your calculator. So can we do p equals to 1, 2, 3, 4? 1, 2, 3, 4 कर सकते हैं, but उसमें ज़्यादा working नहीं होगी. 1, 2, 3, 4. That way you'll have to find out 4 values. This way you have to find out 3 values. Same thing, वैसे. Okay, so navigate to where you see distribution. This is binomial PD, okay, which is at number 4. So you press 4 for that. Press list. Press the equals to sign. नहीं, पहले आप डालें 5, 6 and 7. Press the equals to sign. What is the value of n? N is basically the number of trials, which is 7 here since we're talking about a week. And what is the probability of success? That's 0.65. ठीक है, अब हम एग्जामिनर को थोड़ा बेवकूफ़ बनाते हैं कि हमने कैलकुलेटर यूज़ किया है, हालांकि हमने नहीं किया. So कि हमने वो किया है manually किया है, हालांकि हमने नहीं किया. So we're going to write down these values correct to 5 significant figures, so that in the end 5 or 6, so that in the end we can give an answer correct to 3. So 0.298 0.298 yeah 48. How many significant figures is that? 5. That's good enough. Then we have 0.18477. How many significant figures is that? एक और चलो ऐड कर लेते हैं. And then we have finally 0.049022. Okay, that's good enough. Acha, I don't know if this is possible in your calculator or not. I don't have your calculator with me. I don't know. Okay, just figure it out yourself. Write the name of your calculator, then write Binomial on YouTube. See if there's a video which teaches you how it's done. If it does, then that means your calculator does have that feature. If it doesn't, then what can I do? 0.29848 plus 0.18477 plus 0.049022. Then you do 1 minus the answer and you should get the correct answer, which is 0.467722, which correct to 3 significant figures is 0.468. There we go. Okay. Frequently asked PNC questions. Okay, I'll do that. Okay. So which brand biscuits do you eat? बेटा बिस्किट्स मैं इतना शौक से नहीं खाता. ठीक है, होते हैं तो खा लेता हूँ. It's not that. 3 significant figures is mandatory. Yes. Sir, can you do a question? क्या? What do you mean by that? अच्छा, एक सवाल मुझे आप लोगों को करवाना है, which is from 2025. So just give me a minute. Hold on. Yeah, that's the question that I'm talking about. किसने बोला? Zakaria. Yes. I hope I'm pronouncing it correctly. That is exactly the question that I'm talking about. Just give me a minute. Okay, so I have some questions from 2025. Let's solve them. I know the screen is black. Okay. Here we go. Let's do this. A fair 6-sided dice with faces labeled 1, 2, 3, 4, 5, and 6 is thrown repeatedly until a 3 is obtained. So those of you who are saying, how do we know that this is binomial or geometric? Notice that it says we're going to keep throwing it until a 3 is obtained. That means it's geometric. So then it says find out the probability that x is equal to 8. That means the first success is achieved on the 8th attempt. So first of all, what is the probability of success? The probability of success is 1 upon 3. The probability of not success is, sorry, not 1 upon 3, 1 upon 6 is 5 upon 6. Okay. Okay, now, so if the first success is achieved on the 8th trial, that means the first 7 must have been unsuccessful. Okay, so 5 upon 6 to the power of 7 into 1 upon 6 to the power of 1. Okay, so let's work this out. What do we get? We get 5 upon 6 raised to the power of 6 into 1 upon 6, and that is equal to 0.055 0.055 0.0816, which correct to three significant figures is 0.0558. There we go. Okay. Now, then it says find the probability that x is less than 9, meaning the first success takes less than 9 trials. So what is the probability that x is less than 9? This will be equal to 1 minus the probability that x is greater than or equal to 9. ठीक है बेटा, अभी नमाज में टाइम है, ठीक है. So what is the probability that x is greater than or equal to 9? What is the probability that it takes you at least 9 attempts to clear a test? That means not clearing it in the first 8. Okay. So taking at least 9 attempts to clear a test means not clearing it in the first 8. Same thing. Part 1 wrong किया? कहाँ wrong किया बेटा? सही तो है. 5.6 raised to the power 7 into 1/6. Calculator से गलत किया है. Oh yeah, you're right. I actually did 5/6 raised to the power 7 into 1/6. No, wait. I did something wrong. You're right. Okay. Thank you for pointing that out. 0.046536, which correct to three significant figures, will be 0.0465. Thank you. Okay, now. Achha, what about this? 1 minus, bracket open, 5/6, bracket close, raised to the power of 8. And this is equal to 0.76743. And give this answer also. 3 के बाद और भी बहुत कुछ है, but give it correct to three significant figures. Here it is. There we go. All right, now. Find the probability. Achha, this is a one-of-a-kind question. That a 3 is obtained for the second time before the 6th row. What does that mean? 3 is obtained for the second time before the 6th row. That means you want to find out the probability that you get a 3, not for the first time. Okay, what makes this question unique is the fact that it does not say that a 3 is obtained for the first time before the 6th row. No, it says for the second time. 3 is obtained for the second time before the 6th row. That means it could be that a 3 is obtained for the second time on the 2nd row, on the 3rd row, on the 4th row, or on the 5th row. Okay, so a 3 is obtained. Now this is actually a mixture of multiple concepts. So before the 6th row means what? Before the 6th row basically means that it could be the 2nd, it could be the 3rd, it could be the 4th or 5th. That's what it means. Okay? And it's not for the first time, it's for the second time. Okay? Now, what is the probability of getting a 3 on the second time, for the second time on the 2nd row? Let's have a look at that. What is the probability that you get a 3, you get 2 successes on the 2nd row? That means the first must be success and the second must also be success. Why not first? Is it possible that you get a 3 for the second time on the first row? But a common sense भी use कर लेते हैं. Is it possible that you get a 3 for the second time on the first row? Is it possible? Is it possible that you clear 2 tests by just giving 1? It's not possible. Okay? So I repeat. The question says the probability that a 3 is obtained for the second time before the 6th row. That means it could be that you achieve a 3, or a 3 is obtained for the second time on the 2nd row. A 3 is obtained for the second time on the 3rd row. A 3 is obtained for the second time on the 4th row. A 3 is obtained for the second time on the 5th row. Okay? So what is the probability that a 3 is obtained for the second time on the 2nd row? That's this right here. This means the first one must also be a success. So this will be equal to 1/6 into 1/6. What's that equal to? That's equal to 1/36. Okay? Now what is the probability that a 3 is obtained for the second time on the 3rd row? That means कि Q P P, ठीक है. अब इसका ऑर्डर चेंज हो सकता है, and this can happen two different ways, so we'll just multiply it by 2. So 1 upon 5 upon 6 into 1 upon 6, and this can happen in any order, so we're going to multiply it by 2. Okay, and then the third throw must be a success, so the probability of that is equals to 1 upon 6. 1 upon 6 कहाँ से है बेटा, सवाल तो पढ़ो. What is the probability of success? What is success? Success is obtaining a 3. ठीक है. And what is the probability of 3 on a fair in a fair dice? That's 1 upon 6. अच्छा, इसका क्या रिजल्ट आया? इसका रिजल्ट आया 5 over 108. 5 over 108. Now, what is the probability that you achieve a 3 for the second time on the fourth throw? ठीक है. You get a 3 or a 3 is obtained for the second time on the fourth throw. That means failure, success, failure, success. ठीक है. And this can happen in any order. Okay, this can happen in any order. So we can use binomial over here. We can do 3C1 1 upon 6 raised to the power of 1, and then 5 upon 6 raised to the power of 2. ठीक है. So this is for the first 3 throws, and then for the fourth one it has to be a success, the probability of which is 1 upon 6. ठीक है. And we're almost there. It is a lengthy question, there is no way out. 3C1 into 1 upon 6 into 5 upon 6, the whole thing square. अच्छा, हाथ के हाथ 1 upon 6 पे भी स्क्वायर लगा दो. So this is equal to 25 over 432. And then finally, what is the probability that a 3 is obtained for the second time on the fifth throw? So once again, 1, 2, 3, 4, 5. The first 4 are negotiable, given that we just want one success, can happen in any order. Okay, but the fifth one is non-negotiable. So that means as far as the first 4 are concerned, it's going to be 4C1, probability of success raised to the power 1, probability of not success raised to the power 3, and then into 1 upon 6. ठीक है? Okay, now, so we have 4C1 into 1 upon 6, ठीक है, into hold on 5 upon 6, the whole thing cubed. And what's that equal to? That's equal to 125 over 1944. Okay, now it's time to add them up. So we have 1 upon 36 plus 5 upon 108 plus 25 over 432 plus 125 over 1944. अच्छा, अब देखते हैं इसको करने का आसान तरीका. If there is one, I don't know if there is one, let's find out. 1 upon 36 plus 5 over 108 plus 25 over 432 plus 125 over 1944. So this simplified is equals to 763 3888. There you go. Okay, now this is May June 2025 paper 5 variant 3. Now let's see if there's an easier way to it. 9709 June 25 paper 53. Okay, now कौन सा सवाल है ये? This is question number 3. Let's see if there is an easier way. Okay, no 3s in 5 throws, 1 3 in 5 throws, and we subtract that from 1. Okay. If it occurs to you that this is also a method, then go ahead and do it this way. Otherwise, I would suggest you do it this way only. ठीक है? इसमें yes, there is a lot to write, but the calculation part is not that lengthy. Yes, of course, you do have to write a lot. ठीक है. So I'll give you guys a summary of what I said. ठीक है, then we'll take a break. Now, the question said that we need to find out the probability that a 3 is obtained for the second time before the sixth row. Before the sixth row means that it could be that a 3 is obtained for the second time on the second throw, on the third throw, on the fourth throw, on the fifth throw. So what is the probability that you get 3 for the second time on the second throw? That is if you get 3 and 3. Then on the third throw, that means in the first two, you just need one success, can happen in any order, but the third one has to be a success. So that is why we do this too. Okay? Then what is the probability that a 3 is obtained for the second time on the fourth throw? So the first 3 must have one success, the fourth has to be a success. That's why we use binomial on the first 3. Then on the fifth throw, once again, the first 4 only need one success. That means can happen in any order. That's why you use binomial. And for the fifth one, it has to be a success. That's why you see 1 upon 6. Okay? You can use permutation also. It's the same thing. I mean, if you're talking about factorial, you can use factorial. But what exactly do you mean by permutation? I'm not sure if I understand. But if you're talking about factorial, you can use factorial. Okay? If you're saying instead of 4c1, why don't we use 4p1? That logically doesn't make sense, but it will still give you the same answer, but logically it does not make sense. So, how can you use factorial? I've done another question similar to this where I've used factorial. You guys can check that out. In the meantime, let's take a break. And then after the break, maybe we will look at exactly what the shortcut is that the marking scheme has used. Okay? But right now, let's take a break here. ठीक है, थोड़ी देर में मिलते हैं. Okay guys, let's begin. अच्छा वैसे आई वॉज हैविंग अ थॉट कि क्यों ना आज हम पेपर कब है आप लोगों का? पेपर आप लोगों का है मंडे को. आई वॉज थिंकिंग कि आज हम बाइनोमियल ही आज हम ज्योमेट्रिक ही करके कल हम वो कर लें. टुमारो वी डू बोथ. वी डू नहीं, आज मैं चाय नहीं पी रहा, आज चाय का मूड नहीं है. How about this guys? How about we practice more of, ये बताएं आप लोगों का, do you guys have a paper on Monday? Do you guys have an exam on Monday? नहीं, I know paper Tuesday का है आप लोगों का. I was thinking कि हम normal distribution कल एक detailed normal distribution की stream कर लें. That's what I was thinking. No? नहीं, कल फिर हम PNC भी कर लेंगे. कल फिर we will do normal and PNC, and then Monday को we can have a syllabus run through. let's एक काम करते हैं. अच्छा फिज़िक्स का भी पेपर है ना आप लोगों को? ओके तो चलो let's do 2-3 more questions of geometric at least. ठीक है, फिर हम देखते हैं क्या सिचुएशन है और फिर हम बात करते हैं. ठीक है, ऑलराइट. मॉक देखो, मॉक रखने का टाइम नहीं है, सही है. आई एम अफ्रेड मॉक रखने का टाइम नहीं है. मॉक मैं ये करूँगा कि मैं पुराने, हाँ एक पोल रख लेते ना, दैट्स अ गुड आइडिया. अच्छा बिजनेस P2 भी है मंडे को. चलो फिर एक काम करते हैं, छोड़ो. लेट्स डू इट राइट नाउ. लेट्स डू अ बिट मोर ज्योमेट्रिक एंड देन वील सी इफ वी कैन, देन आई विल कीप अ पोल, फिर डिसाइड कर लेंगे. ठीक है. ओके नाउ लेट्स डू सम मोर क्वेश्चंस फ्रॉम 2025. हाँ ये करते हैं. ओके. Vehicles approaching a certain road junction from B must either go left, right, or straight on over time. Left, right, or straight on. Over time, it is known that 30% turn left, 25% turn right, and 45% go straight on. ठीक है. The driver of each vehicle chooses a direction independently of all other drivers. Find the probability that the next 3 vehicles approaching this junction from B all go in different directions. Okay, all go in different directions. That means that it could be that one goes left, the other goes right, then the other goes straight, or it could be left, straight, right. Nobody has time to, I mean, you shouldn't technically list all the possible arrangements. Instead, what you should do is you should just find out one way and then multiply it by the number of ways this can be done. Okay, so instead of working this out, हम एक काम ये करते हैं, let's find out all the manual ways. ठीक है, let's just find out one way and multiply it by all the possible ways that can happen. ठीक है, so let's just find out the probability of one and multiply it by the number of ways this can happen. So left की क्या probability है? That's 0.30. What's the probability of right? That's 0.25. What's the probability of straight on? That is 0.45. Now what are we going to multiply this with? We're going to multiply this by 3 factorial. Simple. So 0.3 into 0.25 into 0.45. So what's that equal to? That's equal to 0.03375. Since it's, no, wait a minute. Let me double check. 0.3 into 0.25 into 0.45 into 3 factorial. Sorry, I forgot to multiply it by 3 factorial. Into 3 factorial isliye because this can happen 3 factorial number of ways. 81 upon 400, and if you're writing this in fraction form, make sure you write down the exact value. Why 3 factorial? Dekho, is left right straight the only way this can happen? Is left right straight the only way that the 3 drivers all go in different directions, or are there more ways? Is left right straight the only way this can happen, or are there more ways? The question is, how many more ways? Obviously there are more ways. It could be that it's left, straight, and then right, or it could be that it's right, straight, and then left. Now, instead of working them all out manually, how about we just multiply it by 3 factorial? Why? Because these are 3 letters. How many different ways these 3 letters can be arranged? That's simply going to be 3 factorial. Okay, so that's why we don't work it out manually. We just work out one way and multiply it by 3 factorial. So I don't know how much of normal distribution, if I completely watch this stream, do I need to watch your previous stream? I haven't started normal distribution yet. Okay. This is May, June 2025, paper 5, variant 2. Find the probability that from the vehicles approaching this junction from B today, the first vehicle to go left is before the 9th vehicle. Okay, so that means the first vehicle to go left. Achha, first of all, we're interested in left, the probability of which is 0.3. Yeah, the probability of which is 0.3. Which means the probability of failure will be 0.7. Okay. Now we want to find out the probability that the first vehicle to go left is before the 9th vehicle. That means the first success takes less than 9 trials. Now less than 9 means that it could be 8, 7, 6, 5, 4, 3, 2, 1. Now we're not going to work that out. So instead what we're going to do is we're going to do the opposite. We're going to find out the probability of x is greater than or equal to 9 and then subtract it from 1. So what is the probability that it takes you at least 9 attempts to clear a test? That is the same as the probability of you not clearing the test in the first 8 attempts. There you go. Okay, so work this out. What do we get? 1 minus 0.7 raised to the power 8, that's equal to 0.94235, which correct to 3 significant figures is 0.942. Okay. Okay, part C. Find the probability that from the vehicles approaching this junction from B today, the second vehicle to go left is the 7th vehicle. आपको ऐसे लोग सिर्फ मैथ की किताबों में ही मिलते हैं जो ये ऐसी फजूल की ऑब्जर्वेशंस करते हैं. So the first 6 are negotiable. Okay, you just want one success in the first 6, but as far as the 7th is concerned, that has to be a success. So 1, 2, 3, 4, 5, 6, 7. This, in the first 6, you just want one success, which can happen at any time and in any order, doesn't matter. Okay, so that means for the first 6, we're going to use binomial. 6C1, 6 trials, and we want one success. So the probability of success 0.3 raised to the power of 1 into 0.7 raised to the power of 5. Okay, so let's work this out. What do we get? We get 6C1 0.3 raised to the power of 1 into 0.7 raised to the power of 5. What's that equal to? Math error aa gaya. 6C1 के बाद हमेशा multiply लिखा करो calculator में. So you get, irrespective of how you do it, this is what you get. Achha, also, once you've done this, don't forget to multiply this by 0.3 again. Okay, so into 0.3, so you get 0.0907578, which means 0.0976. Correct to 3 significant figures. No, wait a minute. 0.0908, correct to 3 significant figures. There we go. Why 0.7 raised to the power 8? Because not achieving success, taking at least 9 attempts to achieve the first success is the same as not achieving success in the first 8. Okay, why would it shuffle? Read the question. The question says, find the probability that from the vehicles approaching from this junction from B today, the second vehicle to go left is the 7th vehicle. So that means it's the second vehicle to go left has to be the 7th vehicle. Okay, so that means before the 7th vehicle, there has to be one other vehicle which went left, and that can happen in any order. That can happen in any one of the 6 attempts. Okay, makes sense? So because in the first 6 we're doing binomial, that's why we're doing 6C1. The first 6 is binomial, that's why we're doing 6C1. I don't know why you guys are so surprised. We've done so many questions like this already, so why are you guys so surprised all of a sudden? सर P1 के लिए मैंने 4 साल के पेपर्स किए थे, बट देन मैं मुश्किल सवाल नहीं हो रहा था, तो सर S1 से डर लग रहा है, इवन दो ईयरलीज आराम से हो जाते हैं. देखो अगर ईयरलीज आपसे हो रहे हैं and you're timing yourself and you're getting a good score, then that's it. There's no other way that you can test yourself. If you can do yearlies and you're able to maintain a good score over and over again, then that's it. What else do you want? Okay, now, can't you solve it without putting 61? I can, but it's going to be wrong. If you want, I can do it, but answer sahi nahi aayega. So, see, the thing is, why are we multiplying it with 6C1? Okay, you guys need to understand why we're multiplying it with 6C1. The thing is, in the first 6 attempts, we want one success, and that can happen in any order. Okay? So because the first success can occur in any one of the 6 attempts, that's why we're using binomial. Okay? Now, if you want, and this is non-negotiable, the second vehicle to go left has to be the 7th vehicle. So you can't use binomial to solve this question completely. You only have to solve part of this question using binomial, and then you multiply it by 0.3. Okay, yeah, you can do 6 factorial upon 5 factorial. Okay, you can use the factorial method, but I like the binomial method better. Okay, yeah, questions like these are tested very, very frequently. Okay, now अच्छा, अब let's have a poll कि क्या आज हम binomial कर रहे हैं, I mean normal कर रहे हैं या कल. ठीक है. Who's your favorite Ferrari driver? Kimi Raikkonen, hands down. PNC we will do. वैसे आज हम normal करना makes sense. ठीक है, आज हम normal कर ही लेते हैं. ठीक है, ज़्यादा बातें नहीं करते. आज हम I think I already know what the result is going to be. So let's just begin normal. Okay, now. So let's do a question which involves normal distribution and which involves binomial to normal. अच्छा, question number 1 जो है ना वो ज़रा incomplete है. इसको ज़रा मैं कंप्लीट कर देता हूँ, या चलो बाद में करेंगे. विल कम बैक टू इट. Okay, let's do this. Let's do question number 3. Okay, we'll do recent questions also, don't worry. Yeah, we'll do reverse normal also, don't worry. ठीक है. एक second. So question number 3. Okay, now yeah, we'll go over that, don't worry. Acha, in the meantime, let me open up the Z table, which we'll have to refer to over and over. Oops. Okay, now let's do question number 3. In a certain town, the time X hours for which people watch television in a week has normal distribution with mean 15.8 and standard deviation 4.2 hours. Okay, so that means X is normally distributed with mean 15.8. अच्छा बेटा, अब इसमें टॉपिक रिविजन को हमें थोड़ा कॉम्प्रोमाइज़ करना पड़ेगा. ठीक है, इधर टॉपिक रिविजन को थोड़ा कॉम्प्रोमाइज़ कर लो. आई डू हैव अ वीडियो डिटेल्ड on normal distribution. If you want to revise the concepts, you can do it through that. Okay, So this is what the normal distribution looks like. The question says, find the probability that a randomly chosen person from this town watches television for less than 21 hours a week. That means we need to find out the probability that X is less than 21. So the first thing we have to do is that we have to find out the z-score. Okay? Z-score means that we have to find out how many standard deviations away from the mean is this given value. So 21 minus 15.8 divided by the standard deviation, which is 4.2. That means the z-score is equal to what? Z-score is equals to 21 minus 15.8 over 4.2. And what is that equal to? That is equal to 1.238. So remember, always take the z-score value correct to 3 decimal places. Why? Because you can calculate the z-score correct to 3 decimal places and not more than that. Okay, so here you can see is the first decimal place, this is the second decimal place, this is the third decimal place. So whatever z value it is that you're calculating, make sure that you can work it out correct to 3 significant figures. Since we're working out the probability of less than, that means whenever it's less than, what do? Whenever it's less than, the z-score is the value. Okay, so since you want the probability that z is less than 1.238, that means phi of 1.238 is going to be the answer. Okay, why? Some people I know like to draw a bell curve and then do it. So 1.238 will be somewhere over here, 1.238, and what you want is this area, because the area up until this point represents probability. If it was greater than, you would subtract. So let's see what is the z-score of 1.238. So 1.23, that's 0.8907. So अपने calculator में 0.8907 type कर लो. ठीक है, so 1.238. Now, where is 8? Where is 8? Where is 8? Where is 8? What's the corresponding value? 15. So that means plus 0.0015. So what is that equal to? That's equal to 0.8922. So we get the probability to be equal to 0.8922. Okay. Now, what's next? Easy 2 marks. Okay, although I believe this should be worth more than 2 marks. But anyway, 0.892 is the final answer. Okay? 0.8922 or 0.892, correct to 3 significant figures. All right. Now the question says, find the value of k. Sir, I always get confused when the z value is on the left-hand side of the curve. I don't know when to take negative. We'll do such questions. Don't worry. We will do such questions. Don't worry about that. Okay? We'll do plenty of questions to a point where you will find the answer to pretty much every question. If you still don't, we'll work it out. Okay? So could you please explain how to round off z values and table values in marking schemes or sometime round off? देखो, standard rule यही है कि final answer is to be given correct to 3 significant figures. ठीक है? But when you are calculating the z-score, remember z-score is always calculated correct to 3 decimal places. Why? Because you can work out the z-score correct to 3 decimal places. You can find out the corresponding value of z correct to 3 decimal places only. Okay, when do we add 0.5? That is when you do continuity correction. Okay? Find the value of k such that p of x is less than k equals to 0.75. So what is this? This is reverse normal distribution. Okay? Reverse normal, or you can call it inverse normal. Okay, so this is inverse normal distribution. That means this is when you have to read the table backwards. ठीक है, अब ये तसल्ली से करने का सवाल है. So just pay attention and don't panic. That's important. Now, the probability of x is less than k means that we will first find out the z-score, which means the probability of z is less than k minus, what is the mean? The mean is 15.8, so k minus 15.8 divided by the standard deviation, which is 4.2. Okay? This is equal to what? This is equal to 0.75. Okay? This means that phi of k minus 15.8 over 4.2 is equal to what? Is equals to 0.75. Okay, because how do you find out the probability? You find out the probability by taking phi of the z-score. So what is phi? These are all values of phi. ठीक है, ये जो सारी values आप देख रहे हो ये phi values हैं. ठीक है, these values, these are z-scores. Okay, these values combined with these are z-scores, and the probability is basically the phi value. Okay. Now what happens when you take phi across the equals to sign? When you take phi across the equals to sign, it becomes phi inverse. So phi inverse of 0.75. Okay, that means now we have to read the table backwards. Okay, now we have to read the table backwards. So mean and standard deviation always will be used as part 1. Yeah, of course, if the question does not say, if the question does not give you a new set of data, then you'll have to read it from the question. Achha, always look at the standard values that you're given. The standard value is given over here, that 0.75, the z-score of 0.75 is 0.674. Okay, but what if it wasn't given? Let's learn how to read the table. So we're looking for 0.75. Okay, let's see what is the closest we can get to 0.75. So the closest we can get to 0.75 such that it's not greater than 0.75. Okay, we're going to try and make sure that we get as close as possible to 0.75. So the closest we can get to 0.75 is 0.7486. Okay, this is basically the corresponding value of 0.67. Okay, so 0.7486 is the corresponding value of 0.67. But notice that this is not exactly equal to 0.75. So we still have to add something to it. Okay, so the question is, what do we add to it? What do we need to add to it? We need to add 14 to it. So do we have a 14? No, we don't. But we do have a 13. Okay, we do have a 13. And what is the corresponding value of 13? It's 4. Okay, what is the corresponding value of 13? That is equal to 4. ठीक है, अच्छा बेटा अब या तो आप लोग मजाक कर लो या पढ़ लो. ठीक है, so there we go. Now, so 0.674. Okay, 0.674, and here you can see that value. This is already given. If you're lucky, you will find the value in this table. If not, then read the table backwards. Okay, so the answer is phi inverse of 0.75, that's equal to 0.674. So k minus 15.8 over 4.2 is equals to 0.674. Okay, why not 675? Because if you take 675, you will exceed 0.75. Okay, so 0.6, yeah. If you take 5, then it will exceed 0.75. So just make sure that it's either equal to or less than. Okay, so that is why this is what we get. So now all we have to do is cross multiply and find out the value of k. So 4.2 into 0.674 plus 15.8, and that gives us the value of k, which is equal to 18.6308, which means k is equals to 18.6. There we go. Okay. Okay, now let's do another question. अच्छा, जितने भी normal approximation वाले questions हैं ना, that we will solve later. First, let's just do okay, now let's do question number 6. How phi inverse you got? Phi inverse we got by reading the table backwards. So what to do when p is less than 0.5? We'll do such questions, don't worry. ठीक है बेटा, मैं सब छोड़ के आपके क्वेश्चन का तो जवाब नहीं दे सकता ना. ठीक है, so just be patient. We'll do plenty of questions to a point where you'll find the answer to pretty much all your questions. Okay, now trees in the Radian forest are classified as tall, medium or short according to their height. Okay, their heights can be modeled by a normal distribution with mean 40 and standard deviation 12. So x is normally distributed with mean 40 and standard deviation 12. There we go. Trees with a height of less than 25 meters are classified as short. So trees with a height of less than 25 meters are classified as short. Find the probability that a randomly chosen tree is classified as short. That means we need to find out the probability that x is less than 25. Okay, so what's the probability that x is less than 25? For that, we need to first find out the z-score of 25. So 25 minus 40 upon 12, what is that equal to? 25 minus 40 divided by 12, that's equal to minus 1.25. So that means z-score is minus 1.25, which means we need to find out the probability that z is less than minus 1.25. Okay, which basically means that we need to find out phi of minus 1.25. Now, can we do that? Can we find out phi of minus 1.25? No, we cannot. So what do we do in a scenario like this? We do 1 minus, okay, we do 1 minus phi of 1.25. Okay? Why is it that we don't have to, why is it that we do 1 minus phi of 1.25? Here's the reason. So make a bell curve. Okay, so here we have 0. Phi of less than minus 1.25 means that we want this area. This is minus 1.25, that means we want this area. Now we can't really find out this area, so instead what we do is, we know that it's going to be the same as this. So we know that this area where it's less than minus 1.25 is going to be the same as greater than positive 1.25. So how do we find out this area? We do 1, which is all this area, from where we subtract phi of 1.25. Okay, and this is what we get. Okay, now, so let's work out phi of 1.25. Let's see what we get. So phi of 1.25. So 1.25, that's equal to 0.8944. So 1 minus 0. कितना था? 8944, 1.25. Yeah, 8944. 8944. Okay, let's see what we get. So 1 minus 0.8944, what's that equal to? That's equal to 0.1056. Okay, which correct to 3 significant figures will be equal to 0.106. Okay, now add maths, yeah, I'll do add maths streams later. Now is not the time, for me at least, to worry about add maths. Okay, now let's do part B. Pay attention. So part B says, of the trees that are classified, no, bell drawing curve is not that important. Okay, I know some people like to do it by making a bell curve, so I'm just doing it for them. Okay, of the trees that are classified as tall or medium, 1/3 are tall and 2/3 are medium. Show that the probability that a randomly chosen tree is classified as tall is 0.298, correct to 3 decimal places. ठीक है, अच्छा इसका part C भी है. Okay, now, अच्छा अब ये कैसे करेंगे? Notice that we have just worked out the probability that a tree is classified as small. Okay, so remember, small plus medium plus tall is equal to 1. Okay? Small plus medium plus tall is equals to 1. Of the trees that are classified as tall or medium, 1/3 are tall and 2/3 are medium. Okay? So 1/3 are tall and 2/3 are medium. Okay? So इसका मतलब क्या? इसका मतलब ये है कि the ratio of, ठीक है, the ratio of medium to tall is basically 1:2. Okay, the ratio of medium to tall is basically 1:2. ठीक है, why? Because it says 1/3 are tall and 2/3 are medium. Okay, so I repeat, 1/3, नहीं, wait a minute, medium to tall का जो ratio होगा, that is basically 1/3 are tall and 2/3 are medium. 2:1, sorry, not 1:2, 2:1. Okay, so I repeat, the question says, of the trees that are classified as tall or medium, 1/3 are tall and 2/3 are medium. So that means the ratio of medium to tall trees is 2:1. Okay, अच्छा अब एक काम करते हैं. Let's find out the probability of medium and tall combined. So the probability that a tree is medium or tall, okay, combined, is basically 1 minus the probability of small. Okay, yeah, you can do it through a number line also. Okay, So the probability of medium and tall combined is 1 minus the probability of small, which is 1 minus 0.106. And what's that equal to? That's equal to 0.894. Now what do we have to do? We have to find out the probability that a randomly chosen tree is classified as tall. So tall ka kya ratio hai? Tall is basically 1 upon 3 of the total. Okay, so what we're going to do now is we're going to take 1/3 of the total probability. So 1/3 of 0.894, what is that equal to? 1/3 of 0.894, that is equal to 1/3 into 0.894, that's equal to 0.298, correct to 3 decimal places. There we go. ठीक है. अच्छा, एक चीज़ का ख्याल रखना, वो ये कि when you are using the answer of the previous part in part B, make sure that you use the pre-rounded off value, which is 1 minus 0.1056, that's equal to 0.8944. Okay, and then when you do into 1 divided by 3, this is equal to 0.29813, which then correct to 3 decimal places, as the question says, is equals to 0.298. Okay? So I'll repeat this question. Okay? Here's how it works. In the first part, we just had to find out the probability that a tree is classified as short, and the way to do that is to find out what is the probability that its height is less than 25. Okay, so we worked that out. Okay, now. Then the question says, of the trees that are classified as tall or medium, 1/3 are tall and 2/3 are medium. Okay, that means if you look at the ratio of tall is to medium, let's do this part again. Chalo, main isko dobara samjha deta hu. Okay, let's just do it again. So of the trees that are classified as tall or medium, 1/3 are tall and 2/3 are medium. That means if I look at the ratio of tall is to medium, the ratio of tall is to medium is basically 1/3 and 2/3. That means 1 is to 2. Okay, so this is the ratio of tall is to medium. That means jo tall tree hoga, that is basically 1/3 of total. Okay, but remember, it's talking about of the trees that are classified as tall or medium. Now we just worked out the probability of small. This means tall plus medium plus small, all their probabilities combined will be equal to 1. So tall plus medium is equals to 1 minus the probability of small, which is 0.1056, which means the probability of tall plus medium combined is 1 minus 0.1056, and what's that equal to? That's equal to 0.8944. ठीक है. अब इसमें से tall कितने हैं? इसमें से 1/3 tall है, ठीक है, and 2/3 are medium. So 1/3 are tall and 2/3 are medium. So that means if I want to find out the probability of a tall tree, I will just take 0.8944 and multiply it by 1/3. Okay, that will give me the probability that a tree is tall. So into 1 divided by 3, that's equal to 0.29813, which correct to 3 significant figures is 0.298. There we go. Okay, now part C, find the height above which trees are classified as tall. Okay, so we have just worked out the probability that a tree is not exactly, it's not a confusing question, but you can easily get it wrong. Like for example, but actually it's less confusing because they've given you what the probability should be. Okay, so yeah, find the height above which trees are classified as tall. So the question is, what should be the height greater than for a tree to be equal to tall? Now we already know that the probability of a tall tree is 0.298. We already know that the probability that a tree is tall is 0.298. The question is, what should it be? What should its height be greater than for it to be classified as tall? Okay, so for that, what we'll have to do is we'll have to first convert this x value into z-score, for which we're going to do t minus the mean, which is 40, divided by 12. Okay? And this means that we're now looking for the probability of z being greater than t minus 40 upon 12. This is what we're given. This is equal to 0.298. But we know that whenever it's greater than, what do? We do 1 minus. Whenever it's greater than, we will have to do 1 minus. So 1 minus phi of t minus 40 upon 12 is equals to what? Is equals to 0.298. Okay, so what is 1 minus 0.298? 1 minus 0.298 is equals to 0.702. So 0.702 is equal to phi of t minus 40 upon 12. Okay. Okay, now what happens when we take phi across the equals to sign? It becomes phi inverse. So that means now we're looking for phi inverse of 0.702, and this is when we know that we have to read the table backwards. So t minus 40 upon 12. Okay. I've made a dedicated video in which I've taught that you can do normal distribution using your calculator. Okay, so watch that. आज की स्ट्रीम में हमारे पास टाइम होगा कवर करने के लिए या नहीं, I can't say. So let's look at phi inverse of 0.702. So 0.702. Now we're going to try and get as close as possible to 0.702. अच्छा 702, no wait a minute, 702. अच्छा यहाँ पे हम almost पहुँच गए हैं. All I need to do is I need to add a 0.0001, which I don't think we have. So this is 0.53. Now let's see if there's anything else that we can add. No. So we have to settle with 0.53. Okay, we have to settle with 0.53. So let's go with 0.53. Okay, equals to t minus 40 upon 12. Cross multiply. So 0.53 into 12 plus 40, what's that equal to? That's equal to 46.36. 46.36, which correct to three significant figures will be 46.4. There we go. Yes, you can do a lot of things using your calculator, okay, but you should not do it the manual way also. Yeah, let's do a question where you have to do inverse, जिसमें दोनों inverse होता है. Let's do question number 11. Yeah. Find the lengths of the leaves of a particular type of tree are modeled by a normal distribution. A scientist measures the lengths of a random sample of 500 leaves from this type of tree and finds that 42 are less than 4 centimeter long and 100 are more than 10 centimeter long. So that means the probability that x is less than 4 is equal to 42 upon 500. Okay, but this is a question where you have to find out both. Okay, this is a question where you have to find out both. So if you requested for these questions like these, then pay attention. So the probability that x is less than 4 is equals to 42 divided by 500. What's that equal to? That's equal to 0.084. Then the probability that they are more than 10 centimeter long, how many such do you have? You have 100 of these. So that's equal to 100 upon 500. That means the probability that x is greater than 10 is equal to 0.2. Okay? Okay, now we can use 0. अच्छा क्या हो गया, क्या पूछा आपने? I asked him to so many times. What did you ask so many times? So probability distribution table, sampling PNC, most of the working we can do in pencil. Working, if you want the working to be checked, don't do it using pencil. Sir, can you please teach approximation before we do questions on it? You're talking about normal approximation? Yeah, okay, I'll do that. Okay. Okay, now, sir, they asked about further maths. No, I will not be teaching further maths. I've already answered that question so many times. I do not teach further maths, and nor do I have any plans of teaching further maths. Okay, so I hope we're settled. Now, let's find out the z-score. Now, since we have two values, we'll have to find out two z-scores. Okay? So this means that z1 will be equal to 4 minus mu. Mu is mean, remember, and sigma is standard deviation. Okay, and what about z2? Z2 will be equal to 10 minus, what's the mean? The mean is mu upon sigma. There we go. So this means that the probability that z is less than, how much space do we have? Plenty of space. Okay, so z is less than 4 minus mu upon sigma is equals to 0.084. Okay. Now, since it's less than, that means we will directly take phi of the value. So phi of 4 minus mu upon sigma is equals to 0.084. Now, we know that when we take phi across the equals to sign, it becomes phi inverse. I'm not writing phi inverse in the sense that we will find out phi inverse, but I'm not just adding another step because we're already short on space, and let's make sure that we utilize the space efficiently. So what is phi inverse of 0.084? Is it possible to find out phi inverse of 0.084? चलो लिख ही देते हैं. Is it possible that we find out phi inverse of 0.084? It's not possible. Why? Because the least value that you can find out phi inverse of is 0.5. Okay, the least value that you can find out phi inverse of 0.5. So that means it's not possible to find out phi inverse of 0.084. What do we do at this point? At this point, what we do instead is we find out phi, we subtract this value from 1 and we multiply it by minus. Okay, so we multiply it by minus and we find out phi inverse of 1 minus 0.084. Okay, so that means we're finding phi inverse of 1 minus 0.084, that is equal to 0.916. So 4 minus mu is equals to minus phi inverse of 0.916. Okay, I'll explain how to do it using a calculator. Abhi first, let's do it the normal way. Okay. All right. So we are now looking for phi inverse of 0.916. 916. Okay. Okay, 916. Let's begin from here. Nope, not there. 916, 916, 916. ठीक है, 9162 है. 9147 है. 9147 के end में अगर हम 13 add करें, we can get the job done. Okay, so if I add 13 to 47, this will become 916. Correct? 47 plus 13, that's 50, 60. Yeah. So this is 1.37. Now we're looking for a 13. Do we have a 13? Yes, we do. There we go. So 1.378. Okay, so 1.378 is what we get. So this means this is minus 1.378. Okay, now let's cross multiply. 4 minus mu is equals to minus 1.378 sigma. Now let's keep this as it is. We will come back to it. No need to rearrange. इसको हम बाद में देखेंगे. ठीक है, अभी इसको as it is रखते हैं. All right, now let's look at this value. So because this is greater than, here what we're going to do is we're going to do 1 minus phi of 10 minus mu upon sigma equals to 0.2. Okay, 1 minus phi of 10 minus mu upon sigma. So please solve the question where one value is mean or the other standard deviation. Okay, I'll do that. So can you explain this using the bell curve? Okay. Achha, this using the bell curve? No, this is not possible using the bell curve. ठीक है, इसको बेल कर्व से एक्सप्लेन करना है पॉसिबल, लेकिन just remember the rule that if it's less than 0.5, what you do is you basically subtract it from 1 and multiply it by minus. ठीक है? Okay, now so this now becomes 0.8 is equals to phi of 10 minus mu upon sigma. Beta, watch the part of the stream again, okay? So these are already lengthy questions. In the end, I will give a summary, but I can't teach you exactly how I found out phi inverse of 0 point whatever again. So just watch that part of the stream again. In fact, watch it as many times as you like. So now we're looking for phi inverse of 0.8. Now, if we're lucky, we'll find phi inverse of 0.8 here. But sadly, we're not lucky. Okay, so no problem. Let's find out phi inverse of 0.8 the manual way. So 0.8, 0.8, 0.8, nope, 0.8, 0.8, 0.8. Okay, so we have 0.7995. So this is the corresponding value of 0.84. Now we need a 5 at the end. Do we have that? Yes, we do. Okay, and what is the corresponding value? What is it the corresponding value of? It's the corresponding value of 2. So that means 0.842. So phi inverse of 0.8 is 0.842. And this is equal to 10 minus mu upon sigma. Okay. Now let's cross multiply. We have 10 minus mu is equals to 0.842 sigma. Now you can see that we have two equations. Okay, so we have equation number 1 and we have equation number 2. ठीक है? अच्छा. अब एक काम करते हैं. Let's write one equation under the other. And we will subtract them so that mu gets eliminated. Okay? So let's subtract them now. So we have 4 minus 10, which is equal to minus 6. Minus mu gets eliminated, not by coincidence, but by design. And this is equal to minus 1.378 minus 0.842. That's equal to minus 2.22 sigma. So minus cancel. 6 divided by answer. We have sigma, which is equal to 2.7027. So sigma is equals to 2.7027, which means correct to 3 significant figures. It's going to be 2.70. Okay, now let's find out mu, for which we can use any one of the two simpler equations. I'm going to go with 10 minus mu is equals to 0.842 sigma. And we're going to use the actual value, not the rounded off value. That is 2.7027. Okay. So let's take this value, multiply it by 0.842. Let's do 10 minus answer, and that's equal to 7.72. So mu is equals to 7.72. Why not negative? Why would I take negative 0.842? Since I'm finding out phi inverse of 0.8, why would I take negative? I've shifted this across the equals to sign. 1 minus 0.2 is 0.8, and I've shifted this across the equals to sign. So this is positive. Why would I take negative? Okay. So how should we prepare for P1 round 2? The same way you prepared for P1 round 1. ठीक है. It's not that कि बेटा वो कोई अलग ज़बान में होगा, उसी ज़बान में होगा. So it's just a silly question. Just prepare for it the same way. Keep solving past papers. Don't delay it. Don't put things off. Otherwise, you will forget. Sir, but sampling and distribution tables or diagrams, can't they be done? Okay. If you're talking about like histogram, cumulative frequency, of course, draw those using pencil. But tree diagram also you can draw using a pencil. That's fine. Okay. All right. Now there's more. There is more. The lengths in centimeter of leaves of a different type of tree have the distribution mu and sigma squared. The scientists take a random sample of 800 leaves from this type of tree. How many of these would you expect to have lengths between mu minus 2 sigma and mu plus 2 sigma? Okay, now, when we find out the z-score, we're basically finding out how many standard deviations away is the value from the mean. That's what we're doing. Okay? What we're doing is, we sample spacing भी मैं suggest करूँगा. Sample spacing ठीक है, pencil से कर लो. That's fine. That's fine. So we're talking about 800 leaves. Okay, what are we talking about? We're talking about 800 leaves. Achha. The question says, how many of these leaves the scientists would expect to have lengths in centimeter between. Okay, so सबसे पहले तो हम एक की probability निकाल लेते हैं. We need to find out the probability that x is less than mu plus 2 sigma. Okay, and it's greater than mu minus 2 sigma. Okay, now इतने मुश्किल नहीं है. Honestly, these are very easy. So what are you going to do? You're going to convert them to z-scores. how will you find out the z-score of this? You can do it directly if you think about it, but if you can't figure out the way to do it directly, it's basically x minus mu upon sigma. Okay, how do you convert x to z? Z-score is basically x minus mu upon sigma. So x की क्या value है? X की value है mu plus 2 sigma minus mu upon sigma. And then find out the z-score of this, which will be mu minus 2 sigma minus mu upon sigma. Okay, so what you've done is you've basically converted them from x to z. Okay, so mu minus mu cancel ho gaya, mu minus mu cancels again. So that means what we're looking at, sigma and sigma also cancels, by the way. We're looking at the probability of z to be less than 2 and greater than minus 2. That is what we're looking at. Okay? This means that we will take out phi of 2 minus phi of minus 2. Okay? And there's no way to work out phi of minus 2. So instead what we're going to do is we're going to take out phi of 2 and then minus 1 minus phi of 2. Okay, so here's what we get. We get phi of 2 minus 1 minus minus makes it plus phi of 2. Okay, so in short, long story short, we're looking at 2 phi of 2 minus 1. 2 phi of 2 minus 1. Okay, so let's find out phi of 2. Phi of 2 is simply 0.9772. So that means 2 times 0.9772 minus 1. Okay, so 2 into 0.9772 minus 1. Okay, so we have the probability, but bear in mind that this is the probability of one tree. How many such trees are we talking about? We're talking about 800 such trees. So we're going to multiply it by 800. So multiply this by 800. What do you get? You get 763.52. Now, because we're talking about trees, and trees can only take discrete values, so we'll go with 763. Why are we subtracting from 1? But how do you find out phi of a negative value? Phi of a negative value is always 1 minus phi of the positive value. So beta, you need to refresh your concepts. I'll give you my notes. Okay, I'll upload the notes in the same folder. So I think a lot of you need to refresh your concepts first, and you have time to do it. So the sooner you do it, the better it is. So here are my normal distribution notes. Have a look at it, and let's do a few more questions. Why can I not upload? Okay. Can we take 764? No. No, we can't take 764. देखो 764 हो सकता है marking scheme allow कर दे, but it makes no sense. Because 763.52 means there are 763 complete trees. Okay, the marking scheme might allow that, but logically it makes no sense. It's probably allowing because it's being lenient. Logically it's 763. ठीक है. Let's say मैं आपसे कहूँ कि भाई एक गाड़ी में 11.9 लोग फिट हो सकते हैं, तब आप ज़बरदस्ती 12 तो नहीं बिठा सकते ना. 11.9 से ज़्यादा फिट नहीं हो सकते एक गाड़ी में, तो आप ये तो नहीं कह सकते कि चलो 12 बिठा लेते हैं. नो, यू विल से कि भाई 11.9 है तो 0.9 का हमने क्या करना. Okay, so we're gonna go with 11. ठीक है. Sir, have you met? Yes, of course I've met Sir Zain in person. यार बेटा आप इतने बेचैन क्यों हैं ये सवाल पूछने के लिए? कोई आपने I think 25वीं दफ़ा ये सवाल पूछा है. ठीक है, अब पता चल गया आपको. How is your life different now? Now that you know Sir Zain and I have met, how is your life different now? So what about the 0.9%? Exactly my point. व्हाट अबाउट 0.9 आप कोई उसका हाथ वाथ काट के तो नहीं बिठा सकते ना आप. Sir, do you know any teacher that teach computer science? Yeah, I know plenty of teachers that teach computer science. Sir, Taha hai na? Papers doc. Wasn't there supposed to be a boxing match between you two? मैं तो रेडी हूँ, आप लोग बता दें भाई. When, where, I'll show up. Sir, would P1 retake be more harder? बेटा मुझे नहीं पता. I don't work for Cambridge. ना ब्रिटिश काउंसिल में मेरे रिश्तेदार काम करते हैं, ना पेपर बनाने से पहले वो मुझे फ़ोन करते हैं कि कैसा पेपर बनाएं. So I don't know. ठीक है. So for the love of God, please stop asking me about what's going to happen in the P1 retake. I don't know. ठीक है. Sir, as a nation, you can fit 30 people in a 12 people car seat. Okay. चलें कंटिन्यू करते हैं. अगर वो भी लीक हो गया तो हो गया भाई, अब मैं क्या कर सकता हूँ. Alright, let's do this question. अच्छा, I think इसका जो हम पार्ट 2 है ना, इसका पार्ट 2 हम कल रखेंगे. ठीक है. We will do part 2 of this tomorrow, where we learn how to convert binomial to normal. Okay, and we'll do some more normal distribution questions, and then tomorrow only we'll have another stream of permutations and combinations. Okay, so that we have Monday for screen stuck. Okay, अच्छा आपने बता दिया. Okay guys, take it easy. There we go. यार वो द वर्ड लीक मैंने चैट में डिसेबल किया हुआ ना, तो अब ये स्मार्ट लोग उसको उल्टा लिखते हैं. मैं ये भी डिसेबल कर दूँगा. सिंपल इज दैट. ठीक है. सर आप डिस्क्रीट एंड परमू. डिस्क्रीट मैं कर चुका हूँ. परमिटेशन कॉम्बिनेशन आई विल डू टुमारो इंशाल्लाह. ठीक है. ओके नाउ how to get registered for what? Anyway, now a company produces a particular type of metal rod. The lengths of these rods are normally distributed with mean 25.2 and standard deviation 0.4. A random sample of 500 of these rods is chosen at random. How many rods would you expect to have a length that is within 0.5 centimeter of the mean length? Okay, what does it mean by within 0.5 centimeter of the mean length? That means within 0.5 something means that it could be more than that value, or 0.5 more than that value, or it could be 0.5 less than that value. So within 0.5 centimeter of the mean basically means that it's mu plus minus 0.5. Okay. So this means that you could have 25.2 plus 0.5. Okay. Or you could have 25.2 minus 0.5. ठीक है. अच्छा, अब इसमें जब आप सब्ट्रैक्ट करके z score निकालोगे ना, when you subtract and find out the z score, notice what happens. Okay, I know some of you are itching to tell me the shortcut, so hold on, hold your horses. So 25.2 plus 0.5 is 27.5. ठीक है. And 25.2 minus 0.5, so 25.2 minus 0.5, that's equal to 24.7. Okay. So now when we convert this to find out their z scores, let's see what happens. So how will you find out the z score of 27.5? We'll do 27.5 minus 25.2. No, wait a minute. 25.7. Yeah. Sorry. 25.7. Wait, मैं कहूँ कुछ गड़बड़ है. 25.7. Divided by the standard deviation, which is 0.4. And 24.7 minus 25.2 divided by the standard deviation, which is also 0.4. ठीक है. Okay, I fixed it, guys. I fixed it. Take it easy. I fixed it. Relax. Now, notice what happens. This will be positive 0.5. This will be negative 0.5. So that means we did not have to go through the pain of adding and then subtracting. Instead, what we could have simply done was, we could have simply done 0.5 over 0.4 and then minus 0.5 over 0.4. Okay, so we didn't really have to go through the pain of doing all this. Why? Because in the numerator, we always subtract the mean. Okay, in the numerator, we always subtract the mean. So this is what we could have done directly also. Okay, so we didn't really have to do this. We could have done this directly. Okay, but only if it occurs to you. Only if it occurs to you. If it does not occur to you, then don't waste time looking for a shortcut, because then that shortcut is just going to be counterproductive. So if it occurs to you that you can do a shortcut, and if you've already done questions like this where you've used a shortcut, only then do it. Don't feel any pressure to use a shortcut. Okay? So this will be minus 1.25. So what do we do in a scenario like this? We've just solved a question where we had to find out probability of z, I think less than 0.5 and 0.5 tha kya tha? Khair, 2 tha, I think. Probability of z greater than minus 2, less than 2. So in a scenario like this, if you have memorized the rules or if you've done enough questions, you would know that in scenarios like these, you simply do 2 phi of 1.25 minus 1. Okay. So let's find out phi of 1.25. So 1.25. 1.25 is 0.8925. So 0.8925, 2 times 0.8925 minus 1. So 2 into 0. No, wait a minute. 1.25. Oh, 0.8944. 0.8944. So 2 into 0.8944 minus 1, what's that equal to? That's equal to 0.7888. But remember, we're not supposed to find out the probability. We're supposed to find out how many in a sample of 500 would you expect to have length within 0.5 centimeter of the mean. So you're going to multiply this by 500. Whoops, sorry, not 0.5. You're going to multiply this by 500. So if you multiply this answer by 500, what do you get? You get 394.4. Which means the correct answer will be 394, although the marking scheme does allow 395, but it does not make any sense. Check the notes in description. Check the link in description, sorry. Check the link in description and you'll find it there. Okay, so let's keep it till here only. We will pick this up inshallah in the next class, which will be tomorrow. And tomorrow I'm thinking of doing 2 streams, one for normal approximation and the other for permutations and combinations, so that we have Monday to do. We have Monday for what? We have Monday for क्या बोलते हैं? Yeah, इस तरह के questions. Syllabus run through. ठीक है? S1 मॉक बेटा हमें कॉम्प्रोमाइज़ करना पड़ेगा. ठीक है, आप लोग खुद ही पास पेपर सॉल्व कर लो. S1 का मॉक हमें कॉम्प्रोमाइज़ करना पड़ेगा. What I'll do is I will make my old mocks public so you guys can access those, but the official mocks of S1 I'm afraid will have to compromise. ठीक है? So I hope that's clear. फिर आज यहीं तक रखते हैं. Let's connect tomorrow inshallah. Keep solving past papers, guys. Don't give up. So take care, fellas. Don't end the stream. Then do I let it run till tomorrow? Add a subscriber count. Nah, I don't know. I don't like that. No, my birthday is not on the 22nd June. You got the date right, which is nice. It's on the 22nd of July. Say if it uses greater than instead of within, then you only consider greater than. If it uses greater than, then you just consider greater than. That's it. Okay. Syllabus run through tomorrow. Timings for tomorrow I will announce on my Instagram. ठीक है? अभी थोड़ी देर में I'll sort it out and then I'll announce. ठीक है? So काफ़ी है? चाय अभी वही चाय पीने जा रहा हूँ exactly. I'm gonna go have chai. So that's it, fellas. Take care. have fun. Have a nice weekend, whatever is left of it. So take care. Allah Hafiz.